The Feynman Learning Technique is an effective mental model for developing a deep understanding of any subject by simplifying and explaining complex ideas in plain language. The technique is a practical application of the insight that complexity and jargon often mask a lack of understanding. Below is a detailed breakdown of the Feynman technique, covering its steps, principles, benefits, and practical application. The Feynman Learning Technique, a comprehensive guide. The Feynman technique is a powerful and efficient learning method named after Nobel Prize-winning physicist Richard Feynman, renowned for his ability to demystify complex scientific concepts. The core principle is simple. If you want to understand something at a deep level, you must be able to explain it simply. This process of self-explanation and simplification forces active engagement with the material and helps identify the precise limits of your knowledge. The technique typically involves 4 key steps. 1. Identify and study the concept. 2. Explain it simply, as if to a child. 3. Identify knowledge gaps and return to source material. 4. Organize, simplify, and refine the explanation. Step 1. Identify the topic and map your knowledge. The first step is to choose a specific concept you wish to understand deeply. The topic should be narrow enough to be explained in a few minutes to keep the process manageable. Start with a blank page. At the top of a blank sheet of paper, write the name of the concept you are studying. This blank page serves as your canvas for building understanding from scratch. Write everything you know. Without referring to your notes or textbook, write down everything you currently know about the subject. This act of active recall or retrieval practice is a crucial part of the process, as it immediately strengthens memory and makes existing knowledge more accessible. Step 2. Explain it simply, as if to a child. Next, write out an explanation of the concept in your own words, as if you were teaching it to someone with no background knowledge, like a 12-year-old. The goal is to use simple language and avoid jargon. Avoid complex terminology. When you are forced to use simple language, you cannot hide behind fancy vocabulary or rote memorization. If you find yourself using technical terms, you are likely just knowing the name of something rather than understanding the concept itself. Use analogies. Developing simple analogies can help bridge complex ideas to existing, intuitive concepts. Feynman himself was a master of this, using everyday examples to illustrate advanced physics. Step 3. Identify knowledge gaps and return to source material. This is the humbling yet most important step. When you struggle to explain a part of the concept or find yourself using confusing language, you have pinpointed a gap in your understanding. Pinpoint the problem areas. Every time you get stuck, hit a mental block, or have to refer back to the source material, you've found a weakness. Relearn and fill the gaps. Go back to your study materials, textbook, lecture notes, etc., and reread the specific sections that cause difficulty. Ensure you truly understand the missing piece of information before returning to your explanation. Add missing information. Use a different colored pen to add the missing information to your blank page, visually mapping your improving understanding. Step 4. Organize, simplify, and refine the explanation. The final step is to organize your explanation into a clear, compelling narrative. Streamline your notes. Review your written explanation, simplifying any convoluted language or structure. Ensure the flow is logical and easy to follow. Read it aloud. If possible, read your refined explanation out loud. This helps catch awkward phrasing or areas where the explanation still feels clunky. Iterate and repeat. This process of teaching, identifying gaps, restudying, and simplifying should be repeated until you can explain the topic from start to finish simply and accurately. Principles and benefits. The effectiveness of the Feynman technique lies in several key learning principles. Active recall. It forces you to actively pull information from memory rather than passively reviewing notes. This strengthens neural pathways and improves retention. Understanding versus memorization. The focus is on deep comprehension and the ability to use information in various situations, not just memorizing facts for a test. Immediate feedback. It provides instant feedback on your level of understanding, allowing you to focus your study time on weak areas. Clarity of thought. As Mortimer Adler noted, the person who says he knows what he thinks but cannot express it usually does not know what he thinks. The technique makes your thinking clear. The Feynman technique is not a quick fix, but a process that requires patience and persistence. It can be applied universally.